In this last video of the dynamic programming playlist, we're going to take our dynamic programming solution to the longest common subsequence problem and use the array that we have, or the vector of vectors, our table, in order to find the actual string that was our longest common subsequence, or find a string. It's important to note there that the reality is there could be lots of different strings that are longest common subsequences. While the integer value here is unique, the string itself is not necessarily unique. And so you have to basically make some choices as you go through here, and we're going to return one of the strings that happens to have that length. So what we need to do in here is, after we have gone through and filled in that table T, we're then going to actually make two variables, but not set them to 0, sorry, set I equal to s1 dot length minus 1 and j equals s2 dot length minus 1. I'm also going to make a string the result is going to start off as an empty string, and I'm going to change this so that we return a pair of int and string. So we'll go ahead and we will include, I believe pair is in, actually is pair inside of pair, we'll find out in just a second. It'll either be inside of pair or inside of utility. Make sure this is syntactically happy. Okay. Auto p equals that, and then let's see out p dot first, p dot second, and see how close I am on the syntax there. Pair is not the correct place for it. It's tuple that's actually in tuple. Okay, pair is inside of utility. That was happy, it compiles. And if we run it, we get our answer of 7, but no string, because all that we have is the empty string. So I want to keep going while while I is greater than or equal to 0 and j is greater than or equal to 0. If either one of those goes below 0, well, we're done. We can't add any more characters into our solution. So what happens inside of here? Well, first we need to compare the characters at s1 sub I and s2 sub j, just like we did up here, because if they're a match, then what happens is we know that that character goes into our result, and we decrement our I and j. So if s1 sub I is equal to s2 sub j, what do we do here? Well, as I said, we take the result and we're going to push back s1 sub I. Note that really we're building this from the back to the front. This string result is going to be backwards, and then we're going to reverse it, and the reason is that string doesn't have an efficient push front operation, so we're just going to push to the back, which will be more efficient for us, and then we'll have to reverse the result before we return it. Okay, so we push back that, minus minus I, minus minus j, else, well, what if they're not the same? Well, then the value came either from the I minus 1 or the j minus 1. So how about I say if, and I know that our values are greater than or equal to, so I want to go ahead and use my lookup function. If lookup in t of I minus 1 comma j is greater than lookup in t of I comma j minus 1, so if the value that's at I minus 1 is greater, that means that that is where this came from, and so we decrement I, else we decrement j. And so we're going to wind up walking back through this two-dimensional array. When something matches, we move diagonally, otherwise we move either horizontally or vertically, and come all the way down. And we can reverse the result begin, result end. Let's see if that compiles. And I run, and there's our answer, which for the input that we have down here, you might recall, we have the 5 A's there and a B and a C. Actually, there are multiple B's and C's that we could pick from. This has 5 A's scattered in among the M's, and then a BC at the end. Okay. It is interesting to note what would happen if we put the BC up here. Well, now our longest common subsequence is going to go down to 5, and it should only be the A's. Yeah. Because yes, there's a B and a C that can match up, but as soon as you match this B to any of those B's, you've already skipped over all of your A's. And yeah, and that winds up being a problem. So here's your code. We could obviously make this a bit more compact, but this shows you how you can walk backward through the table that you built to kind of recapture the solution that you have. And this also is a polynomial operation. There's only a single loop here, so and either I or j gets decremented every time. So this is order m plus n, where m and n are the two lengths on there. So it's linear, and that makes us very happy. So all of this is quite fast, and we could run this on very large strings, and it will operate quite quickly. So that's it for dynamic programming.